Hello, and welcome to Theme Thursday here on Answer Everywhere. Today we're taking a look at the Haskell Language Server, which is the Language Server Protocol, or LSP, implementation for Haskell. Last week we looked at the Rust Language Server Protocol, and over the course of many videos in the past, we've looked at a bunch of stuff in the Haskell ecosystem. I spent some time trying to get Haskell Language Server to work on Geeks, and so far I haven't been successful, but I have recorded the debugging stuff I've tried so far, and I'll eventually get it to work. And when I do, I'll post that edited video on YouTube. And speaking of uploading videos, I've gone back and forth on whether I want to keep the recorded live stream, or VOD, as some people say, as the Twitch lingo is, posted. And what I'm thinking now is I'm going to try again to leave the VODs up. If something needs to be edited out, I will keep the live stream listed as unlisted or private until about 24 hours passes and YouTube decides that they'll let me trim things and whatnot. There are a few reasons for that, but the short story is I think that's probably the right thing, especially as I start making other sorts of non-live content. I think that'll make it easier for people to see which is which. And but that being said, I might experiment here or there and see which works best. Overall, I've found the process of figuring out what to do with the live stream stuff to not be ideal. And so I guess it's an ongoing process, and I want to make sure that I set expectations so people know which video to comment on or to interact with. And so for now, there will only be one public version of the video, and so if you see it, that'll be the video that I intend for people to view. But I might, as I said, experiment. Some videos I might post as uploads, and some I might keep as VODs, and just sort of see how YouTube reacts and what workflow feels natural for me. So that's that. All right, so I have the Haskell Language Server GitHub open, and it's in the Haskell GitHub org or group or whatever, and it says the official Haskell IDE support via Language Server LSP successor of GHC IDE and Haskell IDE engine. So we do have a GHC IDE. Hello, Firkin. How's it going? And welcome. I do see this GHC IDE folder here. Hey, Ilyas. Is that let me know if I try pronouncing your name and I pronounce it wrong. Let me know. That way I won't have to keep asking. I'll just do my best. But yeah, how's it going? How are folks doing? So I know that there's some stuff in GHC IDE, and this was the name of the original, or at least an earlier version of this package, and things have been kind of rolled into this meta repo. So I expect there's some stuff there. And what? So a bunch of stuff that I think I'm going to ignore, things like Nix packages, stack, Nix configuration, stack configuration, read the doc stuff, dot files. Tests might be interesting. Source is probably interesting. Some benchmarking plugins. HIE, I think we looked up HIE before. Let me see if I can remember off the top of my head what it was. No, IDE engine maybe? Haskell IDE engine probably. EXE, I'm not sure that I need, and then more dot files. Okay, I think this should be good. GHC IDE and test. We'll move test, I guess, to the end. And then source just has HLS plugin and IDE, and there's not much here. So if you watch the thanks, I'm glad. I'm glad you love the channel. It's great to interact with people. I appreciate anyone who who's commenting on the chat or commenting on the videos or whatever. So if you saw the Rust LSP video, then what we found just by poking around was there was essentially a directory just devoted to implementing a JSON RPC server, and then the rest of Rust Analyzer, which is the repo that contains the Rust LSP implementation. The rest of Rust Analyzer is all the kind of stuff you would expect about making abstract syntax trees and parsing the language, putting it into a tree and doing tree-like things on it, or like searching for packages and all that sort of stuff. Now we have looked more in the Haskell ecosystem. We have looked more at several package managers. We've looked at GHC. And so my guess would be that in Haskell, a lot of the heavy work might be done by GHC and Cabal, but I'm not positive of that. And then somewhere we should see some sort of JSON RPC implementation. In fact, why don't we search directly for the RPC implementation first? So I do have the code downloaded. And let's see if we can do, let's try case insensitive JSON RPC. And we get some stuff in development main, GHC IDE development main. They don't have Haskell syntax. What is up with that? Should be like a Haskell mode, right? There we go. Oh, yeah, there's a bug in the chat. Oh no. Better than most non-Turkish speakers. Oh, cool. Are you from Turkey? There is something going on with the chat, and I don't know what it is. I think there's something also going on with YouTube comments. Things seem to disappear, or search doesn't seem to work the way that you would expect it to. I'm not sure what's going on. This font is a bit large. So I saw something about JSON RPC, and it's just this one comment, right? So I'm not sure. I guess we'll look at this. We'll look at main.hs in due time, I guess, and see what we have. Oh, cool. Well, welcome. How are things in Turkey? I've heard that Turkey is a cool place to visit, but I haven't been there myself. Okay, so I'm just not sure what's in source. Let's look at HLS plugins.hs. We've got loggers. We're importing development IDE. Remember, we've got plugin utils. Are we exporting anything? A lot of it's plugin stuff. Seems to be plugins all the way down, and a huge bunch of if defs. Are we if defing the plugins like HLS lint, explicit fixity, HLS rename? The plugins configured for use in this instance of the language server. They can be freely added or removed to tailor the available features of the server. But we're if defing them, right? So do they have to be known at compile time? And then what's an IDE? Argument main and version. What's main do? We've got pretty logging, default main recorder. So I guess this is some sort of like logging monad. We have some arguments, IDE plugins, and IDE state. And we're going to do some IO. If you write the standard out before run language server, then the language server will not work. We're going to get the version. And we're going to, I guess, parse the args. And they could be things like probe tools, BIOS mode. I forget what BIOS is. I think it does stand for basic input output, but I'm not sure what it means in the context of Haskell IDE, whatever we'll call it. And then we have like run LSP mode. So is this the server? I'm not sure, because I thought that I thought that we saw a server in the GHC IDE folder. So let's look in the GHC IDE folder under source. Development, IDE.hs. We have IDE. Where is this Emacs file I had? I think I closed it. Generics development concurrent SYB. Don't know what that is, and something about fuzzy, maybe fuzzy search. Then we've got cbits, which is presumably FFI to C, but it's just get mod time. I guess get modification time of the files. I guess the IDE the LSP server wants to know maybe when files were modified, and we'll use that to possibly detect if they need to be reparsed or whatever. I'm not sure mod time is the best way to do that. I'm sure that's reasonable. Okay, so Furkan is saying, so many people visit Turkey. Good place for vacation. Cool. But economically in trouble. Yeah, I'm sorry. Do you hear that? Upcoming elections. Oh, no. That's too bad. And Ilias is saying, does those LSP work and Visual Studio extensions to catch the error? Okay, so I was laughing because I saw the comment above it about Furkan saying he's from the internet. Yeah, from the internet is good. Yeah, I think I like the idea of everyone being from the internet. I don't know. So yeah, it will work in Visual Studio. I think Visual Studio is the natural home to most LSP stuff, and probably where all the LSP stuff is best tested, because I believe it was originally a protocol for Visual Studio. But I'm not sure Ilias. I'm not sure what you mean by to catch the errors. But if you, do you mean like what I was trying to get it to work on Geeks? That might be possible. I'm trying to get it to work in Emacs, so I can use Emacs. But the problem I'm running into is that I think the problem I'm running into is that I guess let's talk about it. It's not obvious in Geeks how to install some packages. Like it took me a few moments to figure out like how to get an assembler, because Geeks has this idea that Geeks is going to build all of the packages for you. So there's some amount of like sandboxing in Geeks, and there's not a whole lot of easy to access documentation about like what you need to install to like build stuff manually on your own. And then I was trying to install. It's not the GHC stuff isn't including Haskell Language Server isn't packaged for Geeks as far as I could find. So I was trying to install it with this thing called GHCup. And like a lot of these kind of tools for programming languages, GHCup kind of rolls its own installers based on shell scripts. And those shell scripts do things like create temporary directories to do work in, and then delete the directories if there's an error. And so it's just kind of a hassle to debug. One of the trends that I see happening in tooling in general is everyone kind of wants to roll their own sandboxes, but not all of the sandboxes are like super well thought out. And like if you're trying to work with like a bunch of different tools, each which is trying to control their own sandbox, then things end up kind of being a nightmare. So well, not a nightmare, but things end up having a much greater level of cognitive difficulty. So so I think that's basically the sort of thing, the sort of problem I was running into. It would be nicer for me personally to let the user control the sandboxing, that, and then not have all of the tools try to like hide their stuff in different ways. But I'm not sure if I'm ever gonna get my way. And then Buggy says we are reading LSP stuff too now. Cool. Buggy Worm, what do you mean by we? Do you mean like another, like a group that you're in? Or do you mean we as in us here together? Okay. So I still have no idea what's going on, like where the stuff is, but we have this one main in IDE, but I want to find the other main that I had seen. I guess I shouldn't have closed Emacs. Was I did like find grep of JSON RPC. Oh, it was an IDE main. That is the thing I was looking at. Except on my machine, oh, it's source development. Okay, it's a different directory. Here's source. Oh, GHC, I see. Let's try this one more time. GHC IDE, source, development. I thought that's where I went. And then it's just IDE.hs. No, it's in the IDE directory. And then we get main inside of IDE. Okay. So this looks like a promising directory. Development, GHC IDE, source development IDE. And in fact, I'm pretty confident this is where I want to be. So I'm going to close all this other stuff and see what we can find here. Yeah, absolutely. Us reading together constitutes us reading. No, that's right. You're not just procrastinating. Yeah, we are reading LSP stuff. Yeah, and if you didn't catch it, we read the Rust LSP server last week, and then next week we're looking at Source Graph, which is at least partially based on LSP, but does some kind of LSP type stuff in the browser as opposed to in an IDE. Okay, so here's where I think stuff is going to go down. We have this LSP directory, which looks promising. We have main. We might as well look at main, which should be the server. We've got a GHC directory, which is probably going to be calling the GHC libraries. Core, monitoring. I don't want to know monitoring, spans. I guess I want it all. Maybe I don't want the plugin directory so much as I want the plugin file. Let's start with the plugin file. And I guess I'll reorder these. Then where did main.hs go? Here. All right, main.hs. So I expect this basically to be a server. Let's see if they import anything that looks server-y. Concurrent. It might be useful for servers. And some stats. STM should be software transactional memory. So I guess they're recording stats on the STM usage. Some data stuff. Development IDE. I was saying, I think the last Haskell code base we looked at, that I'm not sure how I like the idea that in Haskell, the first part of an import is not telling you any information about who made the import. And so you don't know like the quality. Like these are three things kind of that are similar in some ways, but they, two of them might be made by like a really serious programmer, and one might be just like something somebody hammered out and then like shoved on GitHub or something. I don't think that's the case at all. I think these are all, I think everything here is high quality. But in other languages, when you import, you have like something like a URL from the import, or you have like a package name, and then everything under that package name is at least like from the same package author. So that gives you kind of bounds on quality in some sense. But I do, now that I'm thinking about it, or now that I'm reading more Haskell code, I guess, I do kind of like that, like this is all data stuff. I know what it all is. It's not like um, in some languages you just have cute names for all the things, and you have to figure out, well, what is this package? Oh, it's just JSON support or whatever. Okay. And then we have development IDE stuff, lots and lots of it. Open telemetry. I don't really see anything web server-y. We've got stuff about heap stats. It's nice to see them recording data. Um, when I tried to use some version of this, I'm not sure if it was Haskell Language Server or an earlier iteration. I was doing it on a pretty big code base. I was doing it. I had to like hack some stuff together to get it to work in the environment I was in. So that was probably a problem as well. But I had like issues with things being slow. So it's nice to see that they're recording stats so that they will know if something is slow and they can improve it, because that's how things improve. And we have command, and the commands are check, db, lsp, or custom. Check, type checks some paths and print diagnostics. Okay, that can be useful. db is, I guess, runs a command in the HIEDB. Is that the, we'll look up HIEDB. We have LSP, run the LSP server, and custom. I think I closed the chat assistance. Is this going to work? I'm not going to log in. Or maybe I will. All right. Haskell syntax is wild. Yeah, it is pretty wild. Oh, okay. I missed a bunch of stuff. Okay, so, or asking because I'm not competent in the subject. What's the difference between LSP and linter? That's a good question. And Haskell syntax is wild. Haskell syntax is actually pretty good once you get used to it, but it is pretty wild in general. What's the difference between LSP and linter? So you know, so maybe the right concept, I guess, is static analysis or static code analysis. There's all sorts of tools where basically the idea is the tool is aware of kind of what the source code means, and the tools are going to provide some sort of support for your IDE that's based on their understanding of what source code means. And the way that they function is they kind of like parse. They do sort of the first few things that a compiler would do is they kind of parse the source code and like make a tree out of it, and from that tree they can suggest various things. So a linter, lint is like dirt or like cat hair or like pieces of cotton that you might have on your shirt or whatever. And you would use a lint remover to kind of remove just sort of like unsightly, but not like deeply filthy stuff from your clothes or whatever. And so the idea of linting in code is basically the same thing. It provides like hints for um, kind of like minor issues you have in your code. So you might, if you have a linter, it might tell you that you're like violating a style guide, or that you can improve this function by like having it be, fewer than 100 letters in its name or something. So that's what linting is about. Linting is often pretty lightweight. A lot of like text editors will execute a linter on every, certainly every file save, maybe like every time you input a line or something like that. And then HLS is doing something a little bit deeper, which is it, well, the main thing I think most people use it for is like having like a lookup table for symbols. So if you can like hover on a file, or if you have like a search interface, you can like type something in, and it will tell you where that thing is defined, or it will find all usages of like the function foo or whatever. And so they under the hood, they probably have similar implementations these days, linters and something like LSP, but they just kind of serve different functions in a similar ecosystem. If LSP breaks, you could blame Microsoft. Yeah, I guess you can. All right. I don't know what. So HIEDB generates references DB from HIE files. I'm guessing references DB is going to be the database of symbols, maybe. Let's ask ChatGPT. I don't think that's how you. It's not how you're supposed to capitalize it. But it provides a command line tool for interacting with a database of information produced by Language Server for Haskell development. It can be used to query information about Haskell modules, functions, types, and more. It can be useful for exploring the structure of large Haskell codebases, analyzing dependencies between modules, and understanding the types and functions used in a codebase. Okay, thank you, ChatGPT. I'm going to ask ChatGPT how its day is going. We've never done this. I'm going to guess it's going to tell me it doesn't care because it's an AI model. It's deciding what it's going to tell me. Yeah. I don't have a feeling. All right, I'll come back and see what it types out. All right, so here's the main server, and DB is going to run some check in the HIEDB. I'm going to think of this as a symbol table lookup. I'm not sure that that's what's going on, but I'll think of it that way. We've got this is LSP command, where it just detects if something is LSP or not, which is interesting. I'm not sure. I guess that's fine. We have a command P, something about parsers. We have a bunch of arguments, including stuff about HLS program plugins, rules, logger, commands, HLS config, handle in and handle out. These are IO handles. I don't know really what an IO handle is, but maybe this is for like redirecting things to like standard out or whatever. And here's a default argument. I guess everything has this kind of log as a first argument. Testing default main. Default main seems important. Let's see if there's a non-default main that we need to see. And then expand files. Okay, so default main seems to be where we're going to do what I'm going to guess is the main server loop. Okay, so fun is going to be equal to do. We're going to use this do notation here to define fun. And then what do we do with fun once we defined it? I'm not sure. Okay, so we've got some locale stuff. We're gonna get the process ID, some logger stuff, line buffering. We'll let HLS plugin be essentially something we get from args. I guess we'll debounce args, and maybe that's to in case you pass the same argument in multiple times. Then we've got the in and out handlers here. We're gonna get the number of processors, so I guess we can use parallelism. And the number of capabilities is going to be a max of 1 and something about dividing the processors by 2 and something about threads. I don't know why we're dividing processors by 2. And what is, so from integral of arg threads is going to take arg threads and turn it into maybe a num or something. And is num processors a function? Oh, it's equal to get num processors. Yeah, I'm not really sure what, I'm not really sure how to parse this. I'm not sure. This is like an argument to maybe, right? And then these two other things are arguments to maybe. Unless these two things are arguments to this somehow. I'm not sure. I'll move along. But num capabilities has something to do with threads and processors. We're going to get the arg commands of, case arg commands of. So this is this is a switch statement in Haskell. And we're going to do different things based on whether the command is LSP or check, which is type checking, or DB, which is looking up things in the HIEDB, or a custom IDE command. And so let's see what so LSP should be run the LSP server. So we're going to, with the num capabilities, I guess with knowledge about like how many threads we can have, we're going to get some offset time, do some logging starting, and we'll get the IDE state somehow. The language context env of config may be file path with HIEDB index Q and IO IDE state. So do you need to start it with a specific HIEDB? And does it build up the DB? Like, I guess one of the things that I'm wondering is, as I'm editing files, is the LSP server updating? And should it? It should, right? But maybe HIEDB is just stuff about dependencies. In which case, how would it work if so how would it work in a mono repo where I can modify my dependencies? I'm not sure. Let's find out more about HIEDB if we can. I already tried this, didn't I? Let's try Google. Documentation. This is, Let's look at create. I'm not sure. We saw it. We have an HIEDB in here. So let's look at the file, the like config file. We have an HIE graph. No, that's an HLS graph, which I kind of want to see. Here's hlint. Who is it asking about lint? Firkin. You know what? We're going to look at the lint file, the lint configuration file. It's just going to have like configuration preferences for stuff. I guess we don't have a .hie file here. So here's hslint. And it's going to say like warnings currently triggered by our code. I guess these are like ignoring things that are default available in whatever whatever lint program they're using. And I guess this says warn if you see something like this: nub sort X, and then maybe right hand side is like this kind of object, nub sort. Condemn nub and friends. I don't know what's bad about nub, but they don't seem to like nub, and so this is some configuration that's saying don't use nub. What else do we have? Things that are a bit dangerous in the GHC API. And if the, I guess, module name is within one of these four things, they're going to do something bad. Maybe, I guess, warn. These are like functions that they don't want. So this is just like, here are functions I don't like, here are packages I don't like, and if somebody in my repo tries to do them, issue a warning. So that's the sort of stuff that you can do with lint. I still don't, well, here's HIE DB create. Yeah, you don't have any feelings or experiences. I'm going to ask ChatGPT, would you, I'm going to ask if it would rather have experiences. And see if I can find HIE DB Haskell tutorial. I'm not finding a lot of documentation. Using databases, then that's going to be like SQL databases. Okay. I'm not finding a bunch of stuff, but I guess one of the questions I have is like, do my dependencies essentially have to be frozen for Haskell Language Server to function properly? Or can I in some way depend on packages that I can also be editing and have them live update? So ChatGPT has no desires or preferences. I just follow a set of rules and generate responses to questions. Yeah, okay. I'll say generate, fine. So generate, I'll ask this if it will generate an a Haskell HIE configuration file. So here's an example. Okay, so this is some markdown, create all stack component, language features. Okay, dependencies. This kind of looks like a stack file. Right. All right, back to the main thing. Okay, so at any rate, we're passing in the with HIEDB. I'm going to get the get IDE state from the root path with HIEDE, HIE chan, maybe a channel. I'm going to traverse some stuff. We'll traverse the current directory, I guess, from the root. T to T, I have no idea what this is, and log some stuff. Maybe this is forcing lazy evaluation. And then the directory is going to be the current directory root, I suppose. And then here we get a comment. We want to set the global dyne flags for now, maybe dynamic flags, so that we can use unsafe global dyne flags even before the project is configured. Okay, I don't know what that means. Then we'll load session, I guess a log session. I don't know what this means. Maybe maybe it can like store a snapshot as log somehow. I don't know. And run subset. Disable run subset if the client doesn't support watched files. So I guess the client can watch files and, maybe say, let me know if this file updates. And if the client doesn't support it, we're going to disable run subset because maybe run subset is only used for watched files. And more options, monitoring, and then we'll call it initialize. I don't know what CMAP is. Maybe CMAP with priority. Oh, this is just log stuff. Args, rules. I don't know where rules came from. Maybe it was passed in. Environment, logger, debalancer, options, HIEDB, HIEChan, and monitoring. Okay. And then we're going to call setup LSP with a bunch of the stuff. We're going to run language server with the stuff. And then we're going to dump STM stats. Okay. And then checking the arg files. Check. Check will do type checking, and arg files should be which files to type check. And then we're getting the HIE-DB location. We're calling run with DB some stuff with HIE channel. And logging some stuff with print string line. Expanding files, I guess, from like things like file globbing. And then we have nub-ord, which I thought they were forbidding. LSP works with absolute paths, so try and behave similarly. Okay. So I guess we're getting the absolute paths. LSP works with absolute paths, with absolute file paths. Okay. And then it's going to look in HIE.yaml files for a control setup. We're going to find Cradle files. So we're going to try to use Cradle. And we're going to nub-ord them again. And we're going to get the length of the cradles. Load session. Do some option stuff. Initialize. And set IDE to the value of initialize. Shake session. I think shake was like new an interface to make. And I guess whatever we're initializing some shake session with the IDE stuff that we got from initialize. We're registering an IDE configuration. And then we're setting files of interest from some stuff and normalizing the file paths. And then whatever partition is, maybe partition is going to parallelize some stuff. And we'll get whether it worked or failed. And then I guess we'll show some things if it worked. And then we'll say completed. And if it fails, it will exit. And for DB lookup, we're looking up in the HIE-DB and got a bunch of juggling stuff around for parsing and whatnot. And it says SQLite, so I'm guessing the HIE-DB uses SQLite under the hood. And then I have no idea what a custom command is, but we'll get the current directory, get the HIE-DB location, and call run with DB on some stuff, initialize, shake session, and whatever CIDE is. Okay, so I'm getting a flavor, and the flavor I'm getting is that we're really heavily relying on HIE-DB for all of the information that we're going to use to serve LSP stuff. Give me 1 second. Okay, So there's a function like run LSP, right? Something. Here, run subset. We want set up LSP, then run language server. And we're importing this from development IDE LSP language server. Let's find that. Maybe LSP language server.hs. Yeah, we get run language server here. This is warning, a copy of DA DAML language server. Try to keep them in sync. This version removes the DAML handling. I don't know what that means. Oh, DAML I think is some, is this like a cryptocurrency thing? Oops. DAML is a Haskell-based language for blockchain. Yeah, so I think the DAML people are the authors of Haskell Language Server, or at least some of the functionality. Let's take a look at run language server. I just want to know what they do at the end. We've got some server definition, prolog action, monad IO, void, until mvar, client message var, void, server, run server with handles, and some stuff. We have set up LSP. But what are they using to actually serve code? I don't know. Maybe Colog? Let's look up Colog. It sounds like it might be a logger, though. Modern logging framework. Shake. We will look up Haskell Shake. Shake is a build system, like Make, but more accurate. Tracing IDE session logger Shake. Import language LSP server. Maybe let's look at server. Okay, here we go. We have request handlers. That's good. But they're not writing their own, are they? Their own server? Wait. We are in server / IDE. We're importing some stuff from language.lsp server. Write Chan. So we're rewriting stuff to Chan, whatever a reactor notification is. Let's see what a reactor notification is. Maybe Haskell reactor. Reactor is task parallel reactive programming. All right. I don't know what VFS is. We've got this Chan stuff. I don't know where the Chans come from. We have reactor Chan. So maybe they are just like writing to, maybe reactor is the thing that's doing, you know, server stuff. I'm going to guess that's what's going on. Is there anything like, do we really want to know anything? We've got these requests. Do we convert anything to JSON or ASON? I'm not sure. From development IDE lsp.server. Oh, this is the module. And that's what we export. Okay, let's see what else we have. Development concurrent. What's concurrent? Strict. I don't care so much about that. DHCID bench HLS graph plugins release source plugins. I think we look at IDE. Okay. Yeah, I'm going to guess that the Chan stuff is somehow doing server stuff. So let's look through some of these other directories. It seems like the Chan stuff is kind of where we get the server. So that's the server end. And it seems like the HIE stuff is the stuff that builds up the package database and the symbols and stuff. We have things like hover definition. I guess let's look at hover definition in language server. Is that what we just looked at? And notifications and outlines in server. And I guess let's go to the end here. I think we just looked at one of these, probably this one. So a reactor chan is a chan of reactor messages. And we have unlift IO channel. What's unlift IO? For unlifting monads. There's something about unlifting IO monads, I guess. But it's got a chan. So a chan is an abstract type representing an unbounded FIFO channel. So Q, right? First in, first out. So it's okay. And we've got like from client, we've got a request handler, which has this explicit for all thing. And we're going to get M, which is a client request. And I guess we'll pass it whatever C is. Something about whether it has tracing and message parameters and a method. Oh, these are all conditions on M, I guess. So the M is the method, and it's going to take an IDE state, I guess, or it's going to take something that has an IDE state, message params, and whatever LSPM is. Oh no, a message params, and it's no. This thing, whatever this argument is going to be either a response error or response result. And this has handlers of server MC. So the request handler is going to take an M and a K. So that's these first two arguments. And I guess it'll return handlers. Or maybe it's going to return a thing that's either a response error or something that returns handlers. I'm not sure. But we're going to call LSP request handler with M on the message. And then we're going to do st at, I think we looked at before. It's kind of like an annotation. Whatever ask is, we're going to set to st, and we're going to get the environment, the LSP environment. And this will let response primes, rest prime is probably response, and whatever run reader unserver m st.resp, doing some, I guess, computation. And then we have some trace handler. We trace with span sp params x, and then we're going to write the channel with whatever reactor request is, some LSP ID. And we've got this monadic bind thing, I guess. Yeah, okay. I'm not sure really what's going on, but this is evidently taking a message and writing a response. I'm not sure what's going on with the types, but it's pretty clear what the function's actually doing. And what I still don't know is like what is actually the server implementation, and it might be just we're writing directly to channels rather than using a pre-existing server framework. Here's outlined at HS. I don't know what outline is going to do. Module outline. We've got an IDE state. LSPM. Yeah, I have no idea what's going on here. Document symbol for decal. Maybe declaration. It's got LHS decals and GHCPS. It's going to return maybe a document symbol. I haven't seen so much the kind of abbreviation heavy approach to Haskell. So this kind of code is much harder to read because you have to kind of reverse engineer what the programmer was thinking when they wrote it. And but we can assume some of this, like maybe loc A is a location in the source code, and we've got a real source span. I don't know what L is. Single variable names are like the standard example of a bad bad variable name. So this is, I guess L is some sort of function. But it's going to do something with a location and a span. So like, I guess some part of a source code. It's going to TI-CLD, who knows, and fam decal, and then TCD fam equals fam decal of some stuff, including L and N, with FD info and FD tie vars. Yeah, I have no idea. And then we're going to, what are we? I think we're just going to return this thing, which is just def document symbol L, with like which is like a record. The name we're going to get from the FD tie vars, and the detail we're going to get from the FD info, and the kind is SK function. I don't know what an SK function is. Here's another example of a function, the document symbol for decal. This is, okay. So these are different, these are like polymorphic implementations, right? So how do they differ? So the first one is going to return something that's a kind SK function. And these are the things that's passed in. And I guess we're using pattern matching. Is that right? So down here, we're pattern matching on some stuff again. And we have the loc A real source stuff. We've got the TI-CLD stuff, but except instead of a fam decal, we have a class decal. So I guess this is like a family declaration. And whatever, for some reason, this gives us an SK function. And here's a class declaration. And for some reason, this gives us an SK interface. And detail says just class. And then we get children. And what are the children? We've got the def docal symbol with an that's giving us an SK method. And something else that I thought I saw. I guess a class has children, which might be methods. Yeah, I don't know. And what else do we have? So if we don't, so we had a family decal here, class decal here, in there in green. And if we have a data decal, maybe like a data constructor or something. Then what? Then we get an SK struct. That makes sense for a data declaration. So maybe I'm starting to kind of understand what's going on. And then we get a bunch of if, else, and if stuff. It's a little bit hard to read, kind of like macro processing stuff. Then we get a where clause. This is extract and record fields of a constructor. And we have maybe constructor arg record fields. And maybe recon is record constructor. And the type is SK field. Okay, I have no idea what we're doing, but this looks like some of the LSP type stuff. What file is this? This is outline.hs. Outline. So what's SK? What was it, like SK field? Symbol kind. So we're importing symbol kind from language LSP types, which I think I have open. So let's look at LSP types. I think that'll help us get our bearing. Do I not have it open? Well, let's open it. Well, it's not here. Language.lsp.types. I don't know what this language thing is. Let's find it in Emacs. Go to the root, and we'll look for symbol kind. Here's where we're importing it. We have this call hierarchy internal thing, but I don't think we're defining it. So is this a dependency of Haskell Language Server? I wonder if we can look at its dependencies. Maybe we can find like a cabal file or a stack file, and maybe it's just in the root. Here's cabal. LSP types. Is that what we imported? Here's LSP type. Let's find its GitHub repo. It's in Haskell/LSP. Very slow. Yeah, language LSP. Okay, so it's using a bunch of stuff from another project, which is LSP types. Which this is just imports. And here are the types. Here's capabilities, client capabilities, code action, commands. Yeah, so this is a bunch of the actual LSP stuff. But it's not in the LSP server thingy. Let's look at type definition. Yeah, okay. And here we have JSON stuff. Okay. So a lot of the stuff that I found pretty inscrutable seems to come from another repo, which is that makes sense. Let's go through some more of these. Here's just the cabal file. We'll ignore the cabal file. Here's notifications. I'm not sure this is going to be super interesting, but let's see what some of the notifications are. We have when URI file. We have a descriptor, which is going to take a log and a plugin ID and a plugin descriptor. Sorry, and return a plugin descriptor. So I guess this is specifically a plugin descriptor. We get things like workspace, did change, watched files. And this is in LSP. I'm wondering if this is in the other package as well, language.lsp.types as LSP. So whatever lsp.types is doing, it's maybe emitting signals about when things changed. Like text document did save. Okay, so make plugin notification handler. Okay, so this, I'm going to guess that this is essentially emitting a signal that you can subscribe to if you're a plugin. And the signal is this LSP text document did save, which is probably just the type of from the LSP server spec. And maybe this implementation is telling us when to emit the signal. It's a Lambda with this IDE variable. I guess, I don't know what VFS is, virtual file system. And it's going to take some params and an identifier, I guess, so that you can know which file has changed or saved, rather. And inside of lift.io, which we'll just kind of ignore, we're going to do some stuff. So when URI file of URI applied to file, so we'll add file of interest with some arguments about the IDE and the file and maybe whether it's on disk. And then we'll set file modified to true. And then we're going to log some stuff. So maybe I was wrong. Maybe this seems like it's handling the document did save because it's just setting that it's setting in some data structure that the file is modified. So these are all being handled. We're in like some list, right? So what is the list of? The list of plugin descriptors. No? We're going to mconcat some stuff. Plugin notification handlers. Yeah, I don't know. Set something modified. VFS modified. No idea. So what's VFS? Do you get any sort of input state? Maybe we can grep for VFS. We're importing it from types. Let's open Haskell LSP types for real. And keep it open, I guess. Here's VFS. So what is it? Is it virtual file system? Handles the text document did change. Some messages to keep an in-memory file system of the current client workspace. Okay, so this is kind of shadowing the file system with an in-memory, I guess, virtual file system. The server can access and edit files in the client workspace by operating on the VFS in LSP funcs. So we have a virtual file. Cool. And we've got some map. We've got something about logging. A virtual file name. All right, so what is it actually doing? It's got its own logger and it's writing stuff. Cool. Maybe LSP is where you want to be. Let's see if there's a server here. Source language LSP example. LSP is a library for building language servers handling JSON RPC transport. Oh, okay. Keeping track of document state in memory with a virtual file system, responding to notifications and requests via handlers, setting the server capabilities in the initialized request based on registered handlers, dynamic registration of capabilities, cancelable requests, and progress notifications, pushing and flushing of diagnostics. It is part of the LSP family of packages, along with LSP test and LSP types. So what is Haskell Language Server handling? Features. Let's look at features. I guess diagnostics hovers, jump to definition. And it tells you what the LSP method is. Hmm. I don't have a good sense of so somehow this is a level higher, I guess, than the Haskell LSP thing that actually handles things like the virtual file system and and the uh, JSON RPC stuff. And so I'm not sure really but what's going on then. Let's see if ChatGPT knows. Let's see if the internet knows. What? Let's see. I'm not sure. So this is definitely lower level. For more information, I can check this README. And then these are language servers built on top of LSP. So it handles the transport, the VFS, responding to notifications and requests via handlers, setting server capabilities and the initialized request based on registering handlers, dynamic registration capabilities, cancelable requests and progress notifications, and publishing and flushing of diagnostics. There are two example language servers in LSP example folder. Simple HS provides a minimal example, whilst reactor.hs shows how a reactor design can be used to handle all requests on a separate thread, such in a way that we could execute them on multiple threads without blocking. So I'm not sure, if you're using Haskell LSP and like something's breaking or not performing well, I'm not sure how to quickly find where things are going wrong. But let's continue through and see if anything becomes clearer. Did we look at this already? I think we did. Maybe we didn't. Let's look at it again at any rate. So run language server has some logs and some options, some handle stuff, and some mvars. And then we have a client. One of the mvar is going to be for client message. This mvar becomes full when the server thread exits or receive exit message from the client. The LSP server will be canceled when it's full. Then we have some server definition, which seems like these are all stuff from the LSP package. And then some logging. And then until mvar client message var, I guess until the mvar thing is, what is it, full? We're going to call LSP run server with handles on these handles. So we're just calling out to the LSP package, right, to run the server. And so whatever it's doing, it doesn't seem to be like adding anything performance or efficiency wise really to whatever the LSP implementation is. Perhaps we have set up LSP, and we can do things like cancel requests. And we have handlers, mvars. Handle init. This should be like the initialization of the LSP server, perhaps. You can check it's checking whether stuff is canceled. And then we can handle shutdown and stuff. And shutdown's just stopping reactor, shutting down shake. And I guess somehow we're using the LSP request handler. Okay. Yeah, I still don't understand. I guess one way to put the my feeling of not being oriented is that I don't know what is the boundary between this and the LSP package, and like what is the value add? I don't think those are clearly specified in the doc so far. Okay, here's hover definition, and we saw some hover stuff in the LSP thingy, but maybe this is like more advanced hover. Okay, so we have references, IDE state, reference params, go to definition, and hover. So go to definition will take an IDE state and a text document position parameters and LSPM, I guess LSP monad. And I guess we'll get back either a response error or a response result with a text document definition. And that will be the thing that we go to go to the definition. And for hover, we're going to take an IDE state and a text document position params in this monadic context, I guess. And we're either going to get a response error or a hover object. Similarly with go to type definition. Let's look at found hover. Found hover is going to take a maybe range, so optional range essentially, some text, It's going to return an optional hover. And found hover is going to be called on the range and the contents and return just of hover contents applied to markup content and markdown applied to intercalate section separator contents to MB range. I'm not sure. I'm not sure I understand like what intercalate with of section separator contents, that sort of stuff does. But and why is it returning a maybe? Can it ever return nothing? Seems like it can't, because we've got this just here. We've got this request thing, which is respond to and log a hover or go to definition request. And so what is the respond to part? It's going to, okay, so essentially, I guess it's going to call through LSP. But where's LSP being used? Pure write, maybe not found, MB result. And if we get just a path, we're going to log and run request label. And log and run request, it's going to call out the run IDE action. So I feel a little bit like no matter where we are, we're always chasing more and more stuff to kind of find out where an implementation is, which makes it a little bit hard to read. And this is, you know, when code is laid out like this is where it would be helpful to have a working Haskell IDE implementation, an Emacs, which I currently don't have. But I mean, I guess like even when you have that, it's not a great experience to have to like, you know, drill down through like 6 different functions before you find code that actually you can read and see what is implementing what. So it seems maybe a little bit whatever. I don't know what you would consider this style to be, but I find it a little bit hard to get oriented with. Here's HLS graph. Let's see if there's a graph here. Something about paths. Get data IO file path. Development IDE. We have some graph. A bunch of shake stuff. And what was it? Graph database. Internal key map, key set, and rule. And classes in a database. We have a shake database and shake value. Shake run database for keys. So we're just doing some sort of lookup in the shake database. Let's look at what a shake database is. It's used for defining shake systems. A simple example of a shake build system is build the result.tar from the files listed in result.txt. I guess this is just like a database of dependencies, perhaps. Okay, so here's IDE types. I guess let's look at monitoring. We have some semi-group monitoring with an abstraction for runtime monitoring inspired by the EKG package. Okay. So we can register a non-negative monotonically increasing integer value metrics. We can register some metrics, and I guess it will compute things for the registers. Let's actually look up the Haskell EKG package. As you remotely monitor a running process over HTTP, provides a simple way to integrate a monitoring server into any application. So it's a way to add monitoring. Here's IDE plugin. And we've got plugin rules, plugin handlers, and plugin dyne flags. I guess dynamic flags. But I don't know, again, I don't know if like all the plugin stuff is really being handled by the LSP package. Completions, maybe logic. Get context generates a map of where the context is a type and where the context is a value. That is, where are the value decals and the type decals? That seems useful. So you're going to give it a position in a parsed module. It'll return a context. So we've got this stuff. Is L left and R is right? Maybe that's what's going on. And we've got things like the position is inside source span, R is inside source span R. So I guess we're going to walk some stuff and record some stuff. And we're going to return a context. And the context seems to be some sort of map. Or it's a data constructor. The context of a declaration in the program, e.g., is the declaration a type declaration or a value declaration used for determining which code completions to show. Okay, so this is used for determining which code completions to show. So we're keeping track of maybe where we are in the IDE, perhaps, rather than in all of the source code. And based on where we are in the IDE, we're going to do different queries to the underlying LSP server. And so maybe that's really what's going on here is that maybe the LSP server is for, let's say something like source graph. I'm going to keep talking about source graph. I'm not sure really what's going on with it, but I'm going to think of it as kind of like some of the code search stuff we had internally at Google, where you can, that's also in some GitHub repos, where as you're browsing like a read-only version of the code, you might be able to hover over something, and it will tell you, go to this definition or find usages of context or whatever. And so maybe that's what the LSP package is for. And then maybe the Haskell Language Server package is for knowing about the IDE in the context of the IDE and submitting the right requests to the Haskell Language Server. So that would make sense as a kind of cut point between those two things. Well, I guess I'll assume that's the case. Here we have IDE spans, and we have things like at point, common, documentation, local bindings, and pragmas. Let's look at a few of these and see if my theory is correct. Let's look at point. So FOI references at point. Given a file and position, return the names at a point. The references for those names in the FOIs, I'm not sure what an FOI is, in a list of file paths we already searched through. We're going to give it a normalized file path, a position, FOI references. We're going to get some sort of tuple of name, a tuple of lists of name, location, and file path. So FOI references at point, file pos, FOI references asts, maybe ASTs. And we'll do case HM lookup file asts of nothing, and we get empty lists. If it's just har, whatever har is, and then it's kind of, there's only one case, right? I don't know what happened to the rest of the case. I guess the case is just nothing. But where's the end of the case statement? And why do we need one if there's just one? I'm not sure. But we're going to get name at points of whatever HF is in pos and mapping, get the adjusted locations, and then whatever go is, I guess maybe this is some sort of loop. And the refs are going to get from the source span locations, etc. And then we're going to get type refs, etc. Okay. And references at point. And we'll pass in the with HIEDB. So I guess we can look up the references in the HIEDB thing. And we're going to map over names. And I guess for each name, check some stuff and look up in the HIEDB with find references and telling it, I guess, about the module name. Are we iterating over modules? Look for references strictly in project files, not dependencies. Okay, excluding the files and the FOIs, since those are for FOI refs. Why not dependencies? And these are the non-FOI refs, and then for the type refs, we do a similar thing. Then row to loc, we'll take a reference row and return a location. And the range is going to be the range start end. Start is the position from, I guess, the row -1. I mean, maybe adjusting from 1 index to 0 indexed. And then column, that's the start position and the end position. This is just some calculation. Document highlight. Yeah, okay, so this is stuff about cursors and what's at point. And I think this is consistent with my theory. Local bindings, I have no idea. Turn a real source span into an interval. Okay, that's kind of translating from one type to another. Compute which identifiers are in scope at every point in the AST. Use get local scope to find the results. Okay, so this is we have some AST. And we're going to use, I guess, get local scope to get a scope. And we're going to figure out which identifiers are in scope. But where's the AST from? So we're going to give it a ref map. No, so I guess something is a ref map type. Oh, no. Yeah, this is so ref map type. And then we're going to return this thing, which is like a tuple of interval map positions. The thing we're passing in is a ref map thingy. Where does ref map come from? We're importing it from development IDE GHC compat. So I guess the AST is coming from GHC, I think. All right, so I'm starting to get a feeling for how this is architected now. We are relying on Shake for who knows what, maybe building up a database of dependencies. We're relying on GHC for the abstract syntax tree, and we're relying on LSP, the Haskell LSP package for all of the LSP stuff, like knowing what types to query. And I think we're just doing most of the stuff I see that's doing work is about seems to be consistent with the value of this project being in figuring out how to query the LSP server. So this is like the client rather than the server is probably the way to think of it. Is that right? No, because it's called Haskell Language Server and not Haskell Language Client. But no, so that can't be right. It's doing something. I guess the client would be built into the text editor, right? Or a plugin for the text editor. And this is something different. But I guess, no, yeah. So maybe the way to think of it is the job of this is to understand Haskell well enough to query the language server protocol, where the language server protocol is in some sense it's not Haskell aware. And so maybe the LSP package is just doing the non-Haskell aware stuff. And this is maybe like the more Haskell aware layer. I don't know. Did I ever ask ChatGPT what the difference was? Yeah, so what's the difference between the LSP, let's put it in back, take us. LSP Haskell and the Haskell language server package. They differ in their focus and scope. So LSP provides the infrastructure for creating LSP servers in Haskell, provides high-level API for interacting with the LSP protocol, as well as utilities and abstractions for working with Haskell code. It's intended to be used as a foundation for building custom LSP servers for Haskell tools and editors. The Haskell Language Server package, on the other hand, is a pre-built LSP server for Haskell that is designed to work with a variety of text editors and IDEs. It is built on top of the LSP Haskell package, but also includes a number of language-specific features and optimizations, such as support for GHC-specific extensions and fast indexing of Haskell modules. The Haskell Language Server package aims to provide a seamless and consistent development experience for Haskell programmers across different editors and platforms. So in summary, the LSP Haskell package is a general purpose library for building LSP servers in Haskell, while the Haskell language server package is a specific implementation of an LSP server for Haskell that is intended to be used for editors and IDEs. So I guess what it's saying is that the LSP Haskell package, you can in theory use it to build LSP servers for languages other than Haskell, like other than Haskell. So you could use it maybe to build a Python language server in Haskell if you wanted to. I think maybe that's what it's saying. And so I'll ask is the LSP package aware of the Haskell abstract syntax tree? So it says the LSP package is aware of the AST. Is that true? So let's find Haskell LSP package again and see if it depends on HIE. Let's look in Cabal. Don't see it there. Yeah, I don't think it does. Let's clone it. We get hierarchy. We get it in README, and let's see if we can. Yeah, I don't think. Let's try capital HIE. Let's try lowercase ID, lowercase HIE one more time. Yeah, I don't. It doesn't seem like LSP really knows about the Haskell AST. Let's try AST. We get last and master. I think that it's possible that that ChatGPT is just making this up. So I'm going to guess that the LSP package is for implementing LSPs for any language. Does it tell us this? Sure. And then Haskell Language Server, the package that it's its job to be Haskell aware. All right, how long have I been on? Here's my OBS. An hour 34. So I'm gonna try to get to just kind of get through the rest of this stuff. I feel not totally oriented within this code base, which is not so surprising since it's Haskell and relatively complicated. And So I may revisit it, but for example, I don't have a sense of like its performance characteristics, or even really how to drill down into something and find out like what the real implementation is. Um, so I know more than when I started, but I don't feel like I'm very far on the road to mastery of this particular repository. So here we are in pragmas. I guess this is going to be something about being aware of pragmas. Um, get next pragma info with dynamic flags, megv text. So it's just going to, I guess, look in the source file for pragmas. It's got this next pragma info type. We can split some text. We've got a parser of some state, data parser state not done with this next pragma record. Is pragma, just looks, it has a prefix of this thing. Is downward block haddock, I guess maybe this is some haddock symbol, this curly brace minus, and then vertical bar, and then another downward line haddock. Okay. Update line split text edits. We're calling out, we have a lot of LSP text edit stuff. Need to merge tokens that are deleted or inserted into one text edit, each to work around some weird text edits applied in reverse order issue. Huh. So I guess there's some reverse ordering issue that is a bug and they're trying to work around it. IT var sim hash after a block comment is a parse error, so we don't need to worry about it. Okay, so this is some parser stuff. Update parser. Oh, this is update parser state. Let's look at update parser state. It's going to take a token, an LSP range, the other previous, probably the previous parser state, and then the next parser state is going to be returned. And I guess, is this matching here? If the state is parser state not done, then we get the next pragma. They have the default parser state is equal to the previous parser state, and checking whether it's the last, as I guess we said, is last token hash to false because of maybe this comment, and etc. It's a parser mode comment, but it seems to be a parser maybe just for pragmas. You'd think that there would be a more general parser. Here, monitoring, we've got this EKG stuff, which it said it was based on EKG, but we also have open telemetry. So let's look at open telemetry quickly. Dump monitoring to the event log using the open telemetry package. Okay, so we've got some metrics and we're going to use some package that somebody else made for open telemetry support in Haskell, I guess. Here's core. And maybe I should have looked at cores earlier. Let's look at of interest. File exists, not so interesting. Maybe actions, compile, rule types, position mapping, rules, service, shake. Use stale. And I'll close out that directory. But I also have this GHC directory, which I'm just going to guess is interface to GHC. And since we've looked at GHC, I'm not going to dig into it. Then what other directory had I opened? The LSP. I think we looked at all these. And so I guess the last thing we're looking at is core. Okay, so here's core slash of interest. Utilities and state for the files of interest, those which are currently open in the editor. The rule is file of interest. So I guess I have to have a file open in the editor for it to be considered of interest. I don't know if that's an LSP thing. So let's see what LSP has to say about it. Maybe it's not an LSP thing. Okay. All right, but at any rate, Haskell Language Server is going to keep track of it. And what do we have? Of interest rules. This rule, the rule that initializes the file of interest state. It's got a log and it's going to return some rules. And we've got some hash map and some vars, maybe mvars, of interest var and garbage collect var. More shake stuff. We're going to get file of interests untracked. Oh, FOI is file of interest. And we're, I guess, storing them in some sort of hash map. We have some garbage collection stuff. And get file of interest. It's going to take an IDE state, return an IO of the hash map, I guess, that stuff that stores the file of interest things. We can delete a file of interest. And we're calling hashmap.delete. Cool. And kick. Type check all the files of interest. Could be improved. Okay, so kick is going to, I guess, get all the files from the hash map. Do some shake stuff, shake extras. And then let signal message, when testing, do some stuff. We're going to send the signal kickstart. I don't think I've ever seen this. It seems like it's sending a signal, right? And then we're going to do a progress update. And we're going to update the exports map. The results is going to be set to something about uses generate core file, use HIE, AST, etc. And then do some garbage collection stuff. And we're going to set the signal kick done. This is actually pretty interesting. I don't think I've ever seen an explicit call to garbage collection in Haskell yet, and or the emission of signals. But it's pretty clear that we are actually in the core. Here's actions. I'm just kind of curious what kinds of actions there are. Lookup mod, HIE, DB writer, etc., etc. So get at point. Important note, make sure all rules used by these have a persistent stale rule defined, so we can quickly answer as soon as the IDE is open. Even if we don't have persistent information on disk for these rules, the persistent rule should just return an empty result. It is imperative that the result of the persistent rule succeed in such a case, where we will block waiting for the rule to be properly computed. Try to get hover text for the name under point. To current locations, highlight at point, workspace symbols, get type definition, go to definition, uses E, maybe things that use this. Uses E is going to take an IDE rule, KV, K, and a normalized file path, or a list, I guess a list of them, and return a maybe default, or maybe TIDE action with V and a position mapping. So I guess V is some sort of like file, and position mapping will be like where in that file the use is. Let's look at go to definition. It's going to take a normalized file path, a position, I guess of the symbol that you're asking about. And it's going to return an IDE action of maybe location. And I guess the IDE action is for your IDE to handle. So if you're in Emacs, Emacs will somehow jump to the definition, but that's something that only Emacs knows how to do, or correspondingly for VS Code. Okay, so go to definition of file and position is going to call run maybe, do IDE, whatever ask is headed to this thing. Do some more lift IO stuff. To get the abstract syntax tree from HIE, we'll get the import map. I guess that's going to keep track of the imports in the file we're in somehow. And then get a position. I don't know if exclamation mark in this context means strict rather than lazy. And then we're going to call two current locations by mapping over some stuff, by mapping at point dot go to at definition with the HIE stuff and whatever we got from the lookup. Okay. So it's, so core is apparently where a bunch of the stuff is. This is starting to look more sensible. Maybe I should have started in core earlier. All right, so here's compile based on something here. This GHC documentation. Given the list of paths to find libraries and a file to compile, it produces a list of core module values. This looks pretty long. 1,703 lines. Capture splices and depths. Install hooks to capture the splices as well as the runtime module dependencies. Type check helpers. IDE defer, etc. Okay, I'm not going to go into this, but it's starting to be much clearer how this is working, where stuff is. Here's rule types. A shake implementation of the compiler service, built using the shaker abstraction layer for in-memory use. So, can LSP actually compile stuff though? Stuff about linking, the linkable result, splicing. You have HIE kind, whether it's from disk or fresh, HIE AST. So maybe if it's fresh, that means HIE isn't just from on the disk, which I think was a question I had when I first started. HIE AST result is a data type that we're creating here. Save the uncompressed AST here. We compress it just before writing to disk. And it's got a module and an HIE AST, a ref map. And I guess this is a comment about the ref map. Lazy because its value only depends on the HIE AST, which is bundled in this type. Laziness can't cause leaks here because the lifetime of ref map will be the same as that of HIE AST. We have type refs, which are type references in this file, and HIE kind, and this is the HIE file loaded from the disk or freshly computed. Oh, this is a question. Is this HIE file freshly loaded from the disk or freshly computed? Okay. We have things like get parsed module, get located imports, needs compilation, GHC session stuffs, get client settings. So maybe the compiler, what did it say? Something about compilers. The compiler service. Maybe the compiler service is a service that GHC provides to not to compile stuff, but to parse and create an AST and stuff like that. I'm not sure. What are we importing from GHC? We get generics. We've got a graph, core file, compat util. Yeah, okay. Here's position mapping. Either an exact position or the range of text that was substituted. We have lower range and upper range and position to result maybe. From current position, etc. Is delta. I guess. Position delta? How can a position delta not be a delta? We can add delta. We can make a delta, convert a set of changes into a delta from K. So we're going to give it a text document change event, or give it a list of text document change events. And we're going to return a position delta by calling fold L prime on apply change ID delta and the stuff that was passed in, the change events. Cool. And then we can also get a delta from a diff. Here's rules.hs. I don't really know what rules are being used for. Here's the exposed API. Get all transitive file dependencies of a given module. Does not include the file itself. So we get dependencies. We can get the source file, get parsed module. Rules. These typically go from key to value in our oracles. All right, so we have priorities. We have priority type check, priority generate core. So maybe type check is priority 0 is at the top priority. Priority core is -1. Priority of interest is -2. I'm not sure what the ordering here is. And then we have get parsed module, which has a pretty big implementation. Merge parse stuff. What does this have to do with rules? Get located imports rule. Get parsed module definition. report import cycles rule. So here's a rule, get dependency information rule. Let's look at the report import cycles rule. It's taking some log stuff and we're going to return some rules, or rather maybe return, we're in the rules IO. Is that what this means? Got CMAP with priority again. Oh, that's, I keep looking at that, but I think that's just log stuff. And we've got this lambda report import cycles that we're applying to file. We've got this fmap thing. We'll get dependency information from the file, and then I guess convert its path to something to a file ID, and we'll look up in some map, and we'll let cycles equal map baby cycle error in file of file ID, and whatever the errors we got back, and then we'll convert cycles of files into cycles of module names. Okay, and then we'll iterate over the cycle. So the cycle detection is really being done, I guess, by cycle error in file. And here's the implementation. It will take an F. Oh, it's a function, I guess, taking F part of cycle imp fs. And if the 2 second arguments are empty, then we say nothing. Otherwise, we get called toDiag imp mods on FP. Not, let's see. I'm not sure. Where ring, yeah, we're just have to keep chasing down the implementation. Maybe no range, source span to range, etc. Get module name, show cycle mod. I'm not sure. Some cycle detection algorithm that is kind of splayed out. Here's service.hs. And we can initialize the compiler service. Do we get a comment here? I think we saw this. A shake implementation of the compiler service. Let's ignore that. Here's shake. A shake implementation of the compiler service. There are 2 primary locations where data lives, and both of these contain the same data. The shake database inside ShakeDB stores a map of shake keys to shake values. In our case, these are all of type Q to A. During a single run, all the values in the shake database are consistent, so are used in conjunction with each other, for example, in uses. The values type stores a map of keys to values. These values are always stored as real Haskell values, whereas shake serializes all A values between runs. To deserialize a shake value, we just consult values. Okay. It looks like a pretty big file. 1348 lines. We've got this HIE DB writer. We need to serialize writes to the database. So we send any function that needs to write to the database over the channel, where it will be picked up by a worker thread. We've got this HIE DB writer, which has a queue and some stuff like a pending completed progress token. This seems like, I'm not sure you should be implementing your own database serialization logic in an LSP server. And maybe you should, but it seems like serializing the database is something that is very easy to get wrong or to make not performant. And it seems like the database people have kind of figured it out, but maybe they know what they're doing here. I don't know. We've got some, whatever an index queue is, actions to queue up the index worker thread. Yeah, this is kind of like job schedule-y stuff and database database serialization. And we've got information to stash inside the shake extra field, like LSP, env, global, state, diagnostics. I still don't know, like, why are we using shake? Isn't shake a build system? Let's see if you can find out what's being imported from shake. These are we have shake values, shake database, shake get database keys, development IDE type shake. I don't know. Let's try shake database again. I guess maybe since they built the build system, um, they've done some of the work for keeping track of like packages and stuff that the Haskell Language Server wants to reuse. Shake is a build system alternative to make, scans, and etc. Reliable and robust, powerful, fast to run. Yeah, I don't know. GHC uses a shake-based build system named Hadrian. Okay, I'm not sure. So with the shake extra stuff, um, last value IO, return the most recent potentially stale value and a position mapping for the version of that value. We have an IDE rule, the shake rule result, shake value show. I think we saw shake rules maybe in the Hadrian video. We can delete values. And we can get known targets. Get all the files in the project. Shake open. Open and IDE state should be using shake shut, I guess, to close it. Shake session init. To initialize a session, I guess you could restart a session. You could enqueue some stuff. Enqueue an action in the existing shake session. Returns a computation to block until the action is run, propagating exceptions. And some stuff about hidden diagnostics and keys. You can run an IDE action, which I think we saw a run IDE action called somewhere. It's going to take a string, some shake extras, and it's going to return an IDE action. And an IDE action is going to do some IO. And it's going to use the run reader. And ask shake is just defined to be ask. Okay. Well, I don't really know, but something about using shake and rules, and probably it connects up to what we saw in the Hadrian video. But just exactly how, I don't know. Here's use stale, and we're gonna keep track of some age, the data kind of be tracked, and then some value tagged with its age. All current ages are considered to be the same thing, but stale values are protected by an untouchable variable to ensure they can't be unified. And then we have a position map. And we have tracked stale, which is a pair containing tracked stale, as well as position mapping that will pass forward values to the current age. And then you can make things current. All right, well, let's close everything out. So that's Haskell Language Server. I don't feel like I understand what's going on, but I do understand some things. So we the LSP stuff is really being handled by the LSP package Haskell/LSP on GitHub, and then this is providing essentially a more Haskell aware layer, whereas the LSP layer seems to be just more like language agnostic. And so this is specifically a Haskell implementation of an LSP server, whereas I think in theory potentially you could implement an LSP server for any language using the Haskell LSP package. And there are some major dependencies that are built into Haskell Language Server. One is Shake, which they're doing. I'm not quite sure what, but probably something around understanding the things like dependencies in package databases. They're getting AST stuff, it seems like, from GHC. And then there's this HIE database stuff, which we didn't really look at, I don't think. That's building up a database of kind of like symbols based on what you have in your directory and also your dependencies. And actually, maybe as I'm saying this, I'm realizing that maybe I should actually take a look in one of the HIE directories just to kind of sanity check that last thing I said. So HIE compat. I think, is HIE a separate repo? Let's see if we can find GHC HIE. Yeah, so HIE, let's see, Haskell IDE engine has been merged with Haskell Language Server. So, but we have this compat directory. Let's look at the compat. And we have source GHC, compat. Mainly a backport of HIE files for GHC 8.8. This does not let you read HIE files with mismatched versions of GHC. Okay, here are HIE files. Or at least the HIE files are a proposed new file type that should be written by GHC next to .hi files. The problem, GHC builds a wealth of information about Haskell source as it compiles it, but throws all of it away when it's done. Any external tools that need to work with Haskell source need to parse, type check, and rename files all over again. This means that Haskell tooling is slow and has to rely on hacks to extract information from GHC. Cool? Allowing GHC to dump this file to disk would simplify and speed up tooling significantly, leading to a much richer and productive Haskell developer experience. And then we have some proposal for exactly how things go. It's something about AST, validation of ASTs. There are many simple validation tests enabled by validate HIE. We have some use cases. Haddock should be documentation, an indexer that scans the HIE files, and sophisticated analysis of the HIE. Okay, so HIE seems to now be built into GHC. And so that makes it, so when I'm saying it's getting the AST stuff from GHC, the mechanism, I guess, by which it's getting that is essentially GHC is going to dump these HIE files as it's processing, and those are the things that Haskell Language Server is looking into to see the structure of the code. So that's Haskell Language Server. Tomorrow we're doing our first fan request roulette. So I've gotten a bunch of fan requests, and we will choose one randomly tomorrow and then look into it. And that's all for me.